Welcome back. Continuing on with identifying horizontal and slant asymptotes, we just looked at two examples that both ended up with a horizontal asymptote of y is equal to 0. We're now going to look at a more complicated situation, a situation where we have the degree of the numerator the same or greater than the degree of the denominator. So if I look at this first question here, y is equal to 4x squared plus 3x minus 2 over negative 3x squared plus 4. The degree of the numerator is 2 because I have an x squared term, and the degree of the denominator is also 2 because I have an x squared term. So I have this situation here where I have the degree of the numerator and denominator are equal, so I'm going to take the ratio of the leading coefficients. So the leading coefficients, a sub n is going to be 4, and b sub m is going to be negative 3. So my horizontal asymptote becomes y is equal to negative 4/3. But I don't necessarily need to just have this memorized. If I see that the degree of the numerator is not smaller than the degree of the denominator, I'm going to want to get my equation into this form. And I'm going to do that by factoring using long division and synthetic division. This particular problem, I'm going to need to use long division. If you are having trouble or if you don't remember how to do long or synthetic division, now is a good time to go back and practice or to look up how to do it. All right, long division. The way I'm going to set this up is I have 4x squared plus 3x minus 2. So I write the numerator. And then I'm going to write the denominator, not skipping terms. So minus 3x squared plus 0x plus 4. I really find that keeping a 0x in there keeps me from making simple, silly mistakes. So now I'm asking myself, what do I need to multiply negative 3x squared by to make it into 4x squared? And that is negative 4/3. So if I multiply this whole equation by negative 4/3, I am going to get 4x squared plus 0x minus 16 over 3. And if I subtract that, I am going to get 3x plus 10/3. This is my remainder. And if you remember back to what we do with this equation, this division becomes this piece, negative 4/3 plus the remainder, 3x plus 10/3, divided by the denominator, which was negative 3x squared plus 4, which is not factorable. I want to look at it like this, so I'm going to rewrite it. Y is equal to 3x plus 10/3 divided by negative 3x squared plus 4 minus 4/3. This piece here, as x approaches positive infinity or as x approaches negative infinity, y is going to approach, or this quantity is going to approach 0. Because the denominator is going to get bigger so much faster than the numerator. So when the degree of the numerator is less than the degree of the denominator, this approaches 0. So when this approaches 0, y is going to approach negative 4/3. So this becomes my slant asymptote, or my slant or my horizontal asymptote. Okay, so this piece here becomes my asymptote. Whatever I end up getting there is going to be my asymptote. So then when I look at this next problem, the degree of the numerator is 2, the degree of the denominator is 1, so this follows the degree of the numerator is greater than the degree of the denominator. I'm going to have a slant asymptote here. So when I have a slant asymptote, I need to go through this division. Luckily, my denominator is set up nicely, so I can use synthetic division. So in this problem, I'm going to use synthetic division. So I write the coefficients of my numerator, 2, negative 9, 9. Remember, you leave a 0 for any term that's missing. X minus r is 4, so 4 goes here. I drop my number down, I multiply it by 4, I add to get -1, I multiply to get -4, and I add to get 5. This is my remainder. This is my constant term, and this is my x term. So this means I'm rewriting this as 2x minus 1 plus 5 over x minus 4. Or if I look at this a little differently, y is equal to 5 over x minus 4 plus 2x minus 1. This piece is going to go to 0 as x gets really big or really small. So this is my asymptote. So I have a slant asymptote here of y is equal to 2x minus 1. And we'll look at what that means to have a slant asymptote in an example, but we're doing either long division or synthetic division. And whatever we get, so we'll get a piece that's a remainder and another piece. The piece that is not the remainder, here and here, becomes the asymptote, and then the remainder gets put over the original denominator. In our next video, we're going to look at some examples of how we'll actually graph these.